Alright, hopefully previous to watching this video, you have done the remainder theorem investigation or warm-up, and so you've got an idea of sort of where we're headed here. The formal definition for remainder theorem is what I have written at the top here. When a polynomial f of x is divided by a factor x minus p, the remainder will be the value of the function at p. Pretty interesting. And we use this format to sort of denote that. R of x means the remainder. And then f of p is your function at p. So we'll do a couple of simple examples. In our first one here, we've got a function x cubed minus 4x squared plus 5x minus 1. And in our first example, it's being divided by x minus 2. So our p value here is simply going to be 2. Remember, it's the opposite of the sign that's provided. And I'm literally just going to sub that in. So I'm going to say, well, what's my function at 2? That'll be 2 cubed minus 4, 2 squared plus 5 times 2 minus 1. 2 cubed is 8. 2 squared is 4. We'll leave the 5 times 2 minus 1. Do those multiplications now. I'll have an 8 minus 16 plus 10 minus 1. An 8 minus 16, that'll be negative 8, plus 10 is positive 2, minus 1 is just equal to 1. Therefore, the remainder of my function is going to be 1. That's what's going to be left over when I divide my function by this divisor. Pretty straightforward. Let's do the next one. Here, my p-value is equal to negative 1. It's the opposite of that sign of the divisor. So I sub it in. F of negative 1 will be negative 1 cubed minus 4 times negative 1 squared plus 5 times negative 1 minus 1. Do that multiplication. Negative 1 cubed is negative 1. Negative 1 squared is just 1 times by 4, so that'll just remain the same. 5 times negative 1 will become negative 5, and then I have a subtract 1. Negative 1 minus 4 minus 5 minus 1 is negative 11, so my remainder here is negative 11. That would be left over when I divided my function by this divisor. Okay, a little bit more complicated one. Here we're provided with a divisor that is not in the x minus p format. Uh-oh, dun dun dun. And so what we do, we're just going to rearrange this and we're going to put it there. The way we're going to do that is we're going to take our divisor and set it equal to 0 and just do some rearranging. So I'm at 2x is equal to 3 or x is equal to 3 over 2. And then I just want to rearrange this, bring it back, bring it back over in order to get that x minus p format. If you were dividing, recall that you would not be able to use synthetic division for this. You would need to use long division for this. But we're not dividing. We're just finding the remainder. Okay, we've got our format now, so we know that p is going to be equal to 3 over 2. And let's go. Let's check our function at 3 over 2. I don't know why values are disappearing. There should be an x here. Should be a bracket there. So we'll do 3 over 2 cubed minus 4 times 3 over 2 squared plus 5 times 3 over 2 minus 1. 3 over 2 cubed will be 27 over 8. 3 over 2 squared is 9 over 4. Saving all my multiplications for my next step. 4 times 9 is 36 over 4, which is just 9, actually, so we can just cancel those 4s out. 5 times 3 over 2 is going to be 15 over 2 minus 1. I'll put everything into a common denominator here, which is going to be 8. 72 over 8, 60 over 8, 8 over 8. And then we add, and this one I'm going to need a calculator for. So I've got 27, take away 72, plus 60, minus 8. That ends up being 7 over our denominator of 8. So therefore, the remainder in this case would be 7 over 8. Alrighty. So we've seen two types. Right now it's been pretty straightforward. We've just had it where p is a straight number. Plug it in, get the answer, and that's your remainder. And then we've had one here where we needed to do a little bit of rearranging. Let's go to just a touch harder here. This is a bit more of a thinking problem. When f of x is equal to x cubed plus 3x squared minus kx plus 10. So when this function is divided by x minus 5, I have a remainder of 15, and I need to find the value of k. Okay. So using our remainder theorem, we know that r of x is f at the p-value. R of x is the remainder. We've been given the remainder. It's 15. We could also determine our p-value. The p-value is going to be coming from our divisor. P is 5. So 15 is f of 5. We can actually do f of 5 because we were given the entire function here. We can substitute a 5 in. So it's going to look like this. It'll be 5 cubed plus 3 times 5 squared minus k times 5 plus 10. And we can go ahead and simplify a lot of this. 5 cubed is 125. 5 squared is 25. 5 times k, we can just write 5k. And then I've got a plus 10. Let's finish off that multiplication. 3 times 25 is 75. Okay, I'm going to combine my like terms here. 125 plus 75 is 200, and 200 plus 10 is 210. So I have 15 is equal to 210 minus 5k. Rearrange, bring that 210 over. It'll become subtraction. 15 minus 210 is negative 195. And I divide both sides by negative 5 to get an answer of 39. My k value here is 39 in order for that to be true, for the remainder to be 15 when it's divided by x minus 5. Okay, that sort of was a backward way of thinking about it, really sort of flexing your understanding of remainder theorem and more of a thinking level question. Nicely done, everyone.